Good morning, everyone, or afternoon. I don't know what time it is when you're watching this. But my name is Mr. Lewis, and I'm going to show you guys how to write the code to make your distance sensor work. So, at this point, you should have already finished the instructions for putting together your circuit, including your Arduino hooked up to your distance sensor. Okay, should look something like this. So once you have that done, you are ready to get started. Hopefully you already have the Arduino IDE downloaded onto your computer. So just open up that app, and it should open up to a blank sketch. You'll notice whenever a sketch does open, it is not really completely blank. There's two sections here. We have a setup and a loop. The word void is just basically saying that no information comes out of that section. You don't really need to know the details about that. So basically there's two main sections. There's the setup and the loop. The setup, it will run one time, and that just is where the Arduino just says, okay, these are the tools that I have to use, and the loop is where the Arduino actually performs the functions you want it to perform. Okay. But before we get into a setup, we need to do a couple things. The first thing that you should always do is include a library. A library is basically a big chunk of code that somebody has already written for you to make your job a lot easier. They take hundreds of lines of codes and put them under a small function name or a command name that you can then use. So instead of writing 100 lines of code to do one small thing, you only have to write one line of code that uses the command that they created for you. So that's what we're going to be doing at the beginning. We are going to download a library to use so that way we can simplify this coding process. So the way we find a library is by clicking Tools up on the top and then Manage Libraries. It might take a second, but a window should pop up called Library Manager. This sensor that we are using is called it's printed on it, it's called an HCSR04. So let's look for a library that is called HC-SR04. Okay, so we get a list of them, and you can see that there are a lot here. The one that I like to use is by Dirk Sarodnik. So just click install, just click install and it should install for you. You can see that mine is already installed because, I tested this out, so I had already downloaded this. I like this one. It's the simplest one to use, and it gives you quite a bit of flexibility. But there are other ones, you would just have to know how to use those ones. We're going to be working with this one. Okay, so once you have that one installed, all we need to do is put our cursor right before the very first line here. Hit enter a few times, push that down. In the very first line of code, which actually I'd like to see the line numbers. Okay, so in line number 1, we should hit hashtag include. This tells the program that we are going to be inserting, or we're going to be using some library. and then hit a space, do a left pointing caret, type in the name of the library that we are going to be using, which is hcsr04.h, and then close it by putting a right arrow. This is one of the only lines of code that you will ever be able to write that does not end in a semicolon. It is very unique. These hashtag includes do not require semicolons. Why? Honestly, not really sure. Somebody explained it to me one time. It's very technical, very nitpicky. Doesn't really matter. We just need to know how to write it, and that's how you write it. Okay, so I'm gonna click verify just to make sure that we wrote the correct name of the file. So I hit verify and then I saved it, and you can see that it is compiling the sketch. Okay, it did not give us an error message, which means that we wrote everything correctly. So that's great. Also, I'm just gonna save this as distance sensor 1, so that way we can find it later. Okay, so we now have our library. What else is the Arduino going to need in order to give us distance data? It is going to need to know where or how the sensor is set up. Okay, so basically what pins on the Arduino connect to the pins on the sensor. Okay, so remember we have two different pins that collect and receive data, that send and receive data from the sensor. The first one was called the trigger, and the second one was called the echo. Pin numbers are just whole numbers, so we're going to call these integers. So I'll put int trigger and int echo. And we're going to set these equal to the number of pins that we connected these to on the Arduino. So it looks like I connected my trigger to 2. So trigger is connected to pin 2, and echo is connected to pin 3. Okay. So now the Arduino should more or less know where the pins are. So it should know where to send data and where to collect it from. All right, so we are done with establishing our variables now. The next step is we need to go down to the void setup. We need to start setting things up. This is a code that will run once, and it's basically where the Arduino says, what tools do I need to use in order to perform my tasks? So the task that we're trying to get the Arduino to do is to read distance data from the sensor and print it out so we can see it. So it needs two things. It needs the sensor to be able to read the data from, and it also needs the serial, which is the name of the notebook, essentially, that the Arduino prints information to. Okay, so let's give it the sensor. Let's tell it that the sensor is here. So we'll write HCSR04, all caps. And you can see that turned red. That's because that is a command, which identifies that there is a sensor. So we're telling the Arduino that a sensor exists, and we're going to tell the Arduino to begin using that sensor. All it needs to know now is where those connections are. So we're going to write the trigger. It needs to know where the trigger pin is, and it needs to know where the echo pin is. So we'll write trigger and echo, because then it will be able to say trigger is equal to 2. So we send information through pin 2 to the sensor, and then we're going to listen for information back through pin 3 because echo equals 3. Okay, and then put a semicolon, hit enter. We need to start the serial now. Remember, the serial is just the notebook where the Arduino prints out the information it collects. So we need to write serial with a capital S, dot begin, open parentheses, 9,600, close parentheses, semicolon. So what this is saying is that we're going to start the serial, we're going to open up the notebook, and we're going to begin it. And the 9600 just refers to basically how much information it should expect to get at one time. 9600 is the standard. We're not going to be doing things for, I don't know, we're not really going to do things that go beyond this. So you don't worry too much about the number. You should just know that 9600 is the standard, and that's what we'll pretty much use all the time. Okay, so now everything is set up. So what this is going to read is the Arduino says, okay, we need to look at the library file for all these commands. We need to start up our sensor using pin 2 for the trigger and pin 3 for the echo. And then we need to begin our notebook so I can record all the information. All right. So now we're ready to get into the main code. This is the most difficult part. So the main code goes in the loop, which will run repeatedly forever and ever and ever until the Arduino gets power cut from it. Okay. Or you could put a kill switch in here, but we're not going to do that because we don't really want it to. We want it to keep going. Okay. So how do we do this? Well, the first thing that we need to do is we need the Arduino to create a place to hold the data it gets from the sensor. Okay. Before it can write things to the serial, it needs to go through the Arduino. Okay. The serial, the notebook, is on the computer. The data goes from the sensor into the Arduino and then into the serial. Okay, so the Arduino is kind of the middleman there, right? It's between the sensor and the computer. How can the Arduino store the data temporarily as it transfers it to the computer, into the serial? Okay, so we need to give it that capability. We need to give it a place to hold on to it as it sends it over to the computer, where we can read it. So what we need to do is create a variable where the Arduino can store that information to send out to the computer, out to the serial, so we can see it. The type of variable that we need is called a double asterisk. Essentially what this is a number that has decimals. Whereas up here we had these variables called integers. They're very simple numbers. They are whole numbers. A double is a number that has lots of decimals beside it. This sensor is actually very, very accurate. So it's going to give the Arduino a ton of decimals, a ton of information every time it reads a little bit of data. So we need to store that in a variable that can handle that much information. The type of variable that handles that much information is a double. So what should we call this variable as it transfers? So as soon as it hits the Arduino, the data goes under this label into this double type variable and gets sent over to the computer. What name should we give it? We could call it anything. We could call it Kevin. We could call it Mr. Lewis. But to keep it simple and not confusing, we should call it distance, because that's essentially what is actually going there, is the distance data. Okay, so what should this distance be equal to? It should be equal to whatever this sensor, the HCSR04, measures as distance in centimeters. So, and then we got to do parentheses and semicolon. So what this is saying is we're creating a variable that can hold a bunch of digits, lots of decimal places. The variable is called distance, and that label distance stands in for whatever the sensor reads as the distance measurement. Okay, so maybe the distance measurement reads as like 9.62438 blah 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 on forever and ever. Distance is equal to 9 point whatever I just said. Okay, so instead of having to write all those digits every time, we can just write the word distance, and it knows that you're referring to the information it just got from the sensor. Okay, so we need to be able to read this. So we need to take that variable that exists within the Arduino, and we need to send it to the computer into the serial monitor, or into the notebook, so we can read it. Okay. How do you do that? Well, we say serial dot print, and so that's going to print whatever we put in these parentheses into the serial notebook. And we should put quote D equals space end quote. When you put something in quotations, it's going to put exactly what you put there. And then after that, we're going to put serial dot print open parentheses. We're just going to write the word distance. So I did not put that in quotations because I do not want it to write the word distance. I want it to write the value of the variable distance. This variable distance is equal to whatever the sensor just measured. Okay, so it's not a number. It's not a word. It is some number. But do I really want that many decimal places? Do I want 1,000 decimal places? No, that's annoying. So what we're going to do is we're going to do a square bracket, 0, and square bracket. And basically all that says is the 0 just says that we're going to the hundredths place. So it'll read back 2 decimal places. Yeah. All right, so we're going to do 2 more serial prints, but this time we're doing serial.print ln. What this will do is it'll print whatever we put in the parentheses and then start a new line, which is great, because if we don't do this, then we're going to have things printing side by side and it looks confusing, it looks messy. We want it to read D equals the number, centimeters, start a new line, D equals, you'll see. So then we're going to write quote CM, end quote, end parentheses, semicolon. And then we're going to delay for 250 milliseconds. The reason we delay is because the Arduino runs insanely fast, but the sensor does not run that fast. So in order to get accurate data, we need to tell the Arduino to take a breath and wait for the sensor to collect some more information so it has something to give to the Arduino. Otherwise, we're going to run into some issues. Okay, and there you go. Pretty simple code. There's some more technical things within it, but we should be okay. So let's verify it, make sure we didn't forget any semicolons. Okay, it says that it doesn't give us an error message, so we must have done something right. All right, so now I'm going to plug in my Arduino and point it at something so I can measure the distance. And now I'm going to hit Tools, Port, click on the one that says Arduino Uno, and then click Upload. Okay. So it says it's done uploading. I don't really see anything going on. Well, the reason is because we don't have the serial monitor open. So let's hit Tools, go down to Serial Monitor, and you should see is printing out all these lines. Nice. You can see there's a little noise in the data. Sometimes it messes up, but for the most part, it's hanging around 9.33. If I were to move the thing, okay, you can see that the numbers change wherever I move this thing. Nice. Okay, so there we go. Yep.